Hey guys, it's Miss Johnson and I'm here to bring you our seventh and final notes for Unit 3. Today we're talking about multiplying binomials. So that's our learning target. I can multiply binomials together. So we have two different methods for multiplying binomials. Now we've spent all unit long talking about these properties of powers and exponents, and we're going to use these today when we're multiplying. The first method is to FOIL. So that when we FOIL, these are our steps. This word FOIL is an acronym, that's why it's in all caps. We're going to multiply the first two terms, multiply the outside terms, multiply the inside terms, and then multiply the last terms. We always have to go back and combine anything that's like terms and write it in standard form. But that's what FOIL does for us, is first, outside, inside, last. That's just a way of organizing our distribution. Because really what's happening here is when you have two binomials that you're multiplying together, it's just two sets of distribution. So I have to distribute the first term and distribute the second. This is just an acronym to help us remember that. I can also use what's called the box method. We'll draw a box and we'll line up one binomial on the top and one binomial on the side, and then we'll multiply inside the box. Same thing, right amount, combined like terms, put in standard form. So those are two different methods. You're going to see them a lot today. Go ahead and pause your video to write these down if you need a few extra minutes, and let's get started with number one. And number one, I'm going to use the FOIL method. So I have x minus 1 times x minus 4. So if I use the FOIL, again, this is really just two sets of distribution because this x needs to get multiplied by both parts inside, but the negative 1 also needs to get multiplied by both parts inside the parentheses behind it. So by FOILing, I multiply my first two terms, which is x squared, my outside terms, which is negative 4x, my inside terms, which is negative 1x, and my last two terms, which is positive 4. So first, outside, inside, last, F-O-I-L. And then I combine like terms, negative 4x and negative 1x is negative 5x. So I have x squared minus 5x plus 4. I always want to make sure that it's in standard form. My powers go 2, 1, 0, so that is, and I'm good. Let's try number two using the box. So in number two, if you set up a box on your page, you need a 2 by 2 box. Okay, you need a 2 by 2 box. So I'm going to have two columns and two rows. And what happens here is I put the one binomial on the top, positive 2, and I put the other binomial on the side, positive 5. Okay, so x plus 2, x plus 5. Now I multiply on the inside. So x times x gives me x squared. X times 2 gives me 2x. X times 5 gives me 5x. And 5 times 2 gives me 10. If I write out those terms, that gives me x squared plus 2x plus 5x plus 10. And then combining your like terms, x squared plus 7x plus 10. So that's the box method that I would have there. I always want to write this in standard form, but this one already is, so I'm good with that. Let's take a look at number three. Now, number three is a little bit different because number three has a coefficient out front. So what happens when that happens is I'm going to multiply it through to the first binomial only. I'm going to change that binomial to 3x plus 3. When I do that, the second binomial stays the same. If I were to multiply this 3 all the way across, I'd really be putting in the 3 twice because I put the 3 into the first one and then this whole first one is going to get multiplied by the second. So I don't need to worry about going over to the second because by putting it in the first, it's going to make it over to the second one anyways. So now I'm going to go back and I'll use my FOIL method. I'll multiply my first two terms. That's 6x squared. My outside terms, which is 3x, my inside terms, which is 6x, and my last two terms, which is 3. Putting your like terms together, you have 6x squared plus 9x plus 3. That's the binomial I'm looking at there. Or I should say the trinomial, the simplified expression. Okay, and number four, I'll go back to the box method. There's no coefficient out front to worry about, so I'm just going to set up the box, a 2 by 2 x minus 1, x minus 3, and multiply on the inside. X times x is x squared. X times negative 1 is negative 1x, or just negative x. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Write those terms out. Put your like terms together. X squared minus 4x plus 3. And that's what that looks like. So now let's talk about multiplying a binomial squared. When we have a whole binomial that's being squared, meaning it's a binomial that's multiplied by itself, do not just square both terms. That's what most people want to do. We have to actually multiply the binomial by itself. So this is going to be the binomial times itself. If you just end up squaring both terms, I'll show you what happens, but you lose some. You won't get those middle terms that we need. So let's take a look at number 5 on the back of your page. I have x plus 6 squared. So when I multiply this, this is the same thing as x plus 6 times x plus 6. That is a FOIL question. I need to FOIL this. First, outside, inside, last. So I have x squared plus 6x plus another 6x plus 36. Put your squared terms together and I get x squared plus 12x plus 36. Now, I want to show you what happens if you just square both terms. So this is a don't do this. If you're going to write this down, make sure you write don't do this. Okay? If I just take x plus 6 squared and distribute my square to both parts, that gives me x squared plus 36. Now this is a very, very common mistake. Most students, or a lot of students, have made this mistake in the past. Look at the difference. This is what happens if you just square both terms. This is what you get when you FOIL. You lost the whole middle two terms. These two terms that give you the 12x, where'd they go? Okay, so that's a problem. We don't want to do that. So this is a don't do this part. If you want to write it down to have a bad example, that's fine, but make sure you recognize that it's a bad example. Don't do that. So let's take a look at number 6. And number 6, I'm going to take x minus 2 times x minus 2. I'll set up a box this time. You can use either method that you prefer. If you want to FOIL every time, go for it. If you want to use a box every time, go ahead. I'm just showing you both so that you see the two options. It's really just a way of organizing those two sets of distribution like we talked about. So x gets distributed, negative 2 gets distributed. You've got to keep it organized somehow because it's a lot of terms, so we use these two methods. If I use the box, I get x times x, which is x squared. X times negative 2 is negative 2x. X times negative 2 is negative 2x. Negative 2 times negative 2 is positive 4. Writing out those terms looks like that. Like terms in the middle, x squared minus 4x plus 4, and that is my trinomial. Okay, so now we're going to talk about what happens when we multiply things that are bigger than binomials. So when we have things that are bigger than binomials, the FOIL method does not make sense anymore because we have not just a first and a last. So there isn't just first, last, inside, and outside. We have more terms involved. So when we're multiplying things that are bigger than binomials, we're going to use the box method to help keep our distribution organized, okay? Because it just gets to be a lot of distribution and it's easy to have this big long string of terms and forget things. So let's take a look at number 7. In number 7, I have a binomial times a trinomial. So again, FOIL doesn't work because you have first, outside, inside, and last, but what about this 5x in the middle? That gets dropped off if I use FOIL. So I'm going to set up a box instead. This box needs to be a 2 by 3. So I'm going to set up a box that looks like that. I have 4x and 9 on the side. On the top, I have 2x squared minus 5x plus 3 across the top. Then I find the products on the inside. 4x times 2x squared is 8x to the third. 4x times negative 5x is negative 20x squared. 4x times 3 is 12x. 2x squared times 9 is 18x squared. 9 times negative 5x, negative 45x. 9 times 3, 27. Okay, so Now I want to go back and put my like terms together, and I want to point something out to you. Some of you may have recognized this on the front side of your page, but if you take a look at your box, you can find your like terms on the diagonal as long as your two binomials, the binomial and the trinomial, are written in standard form. Even if they're not written in standard form, you can look inside this box to find those like terms. That's okay. You're allowed to do that if you want to skip the hassle of rewriting the whole long list. Sometimes when we recopy things down, we forget things, we lose things, we make mistakes. So instead of that, we can just combine them from the box. So when I combine my like terms, that 8x to the third is by itself. Then the 18x squared and negative 20x squared, when I combine those, I get negative 2x squared. Negative 45x and positive 12x is negative 33x, and then that 27 is a constant by itself. That is my simplified expression. Let's take a look at number 8. Now in number 8, I want to show you it's not going to make any difference if you make your box vertically or if you make your box horizontally. You could switch the order of your terms, and you can do that in a 2 by 2 box as well. I can put the 3x minus 5 on the top and the 2x squared, 7x, and negative 8 on the side. As long as you keep this whole binomial together and that whole trinomial together, it doesn't matter if you make your box this way or that way. You're going to get the same thing. So 6x to the third, this one's going to be negative 10x squared. That one's going to be 21x squared. That one's going to be negative 35x. This one is negative 24x, and that one is going to be positive 40. So then I look for my like terms. And again, my like terms are on that diagonal. You can see here's your two squared terms to put together, and here's the two x terms that you want to put together. The 6x to the third stays by itself. 21 minus 10 gives me 11x squared. Negative 24 minus 35 gives me, oh goodness, negative 59x, and then that positive 40 is by itself. If we take a look at number 9, now we have another one that has a coefficient out front. You have a 5 on your sheet that's in front of this. So what happens here when we have a 5 that's in front is we need to distribute to the whole first set. Just like we did on the front side, we're only going to distribute that 5 to the first set of parentheses. So when I rewrite that, it looks like this: 5y squared minus 10y plus 25. And then I have 6y squared minus 3y plus 1 that stayed the same. This is a 3 by 3 box. This is a big one. So you need a 3 by 3 box, which is a relatively large box. You can see how this is a nice way to organize your terms, because if I were trying to do distribution, I'd have this one to all three of those. Then I'd have the middle one to all three of those. Then I'd have the last one to all three of those. You end up with 9 terms, which you can see we're going to have in this box here. If you had 9 terms all listed out in a list, it's really easy to lose one or make a mistake. So that's why we use the box to help us keep it organized. So this one's going to be 5y squared, negative 10y, positive 25. This one's going to be 6y squared, negative 3y, positive 1. And then I just go to work. I need to find the products in the middle. 30y to the fourth. This one is negative 60y to the third. This one is 6 times 25. 150y squared. Big terms there. Then middle term, or middle row, negative 3 times 5 is negative 15, and that's y to the third. Negative 3 times negative 10 is 30, and that's y squared. Negative 3 times 25 is negative 75y. Last row, multiplying by 1 keeps everything the same. So now combine your like terms. Here is the third terms. Here are all of my square terms, and this time I have 3 terms that are raised to the second power. Here's my two terms that are raised to the first power. Let's put all those together. The 30y to the fourth stays the same. Then I have negative 75y to the third. Then I have, wow, lots here. Positive 185 y squared, goodness. And then negative 85 y and positive 25 as the constant. I'm in standard form. There's my product. Holy cow. Okay, let's do this one more time and then we have one more problem and we'll be good. So in number 10, I need to set up another 3 by 3 box. I have 3 terms and 3 terms. So here we go. 3 columns, 3 rows. Lay out your terms, m squared, 2m, negative 3, 4m squared, negative 7m, positive 5. And then I multiply on the inside. 4m squared times m squared is 4m to the fourth. 4m squared times 2m is 8m to the third. 4m squared times negative 3, negative 12m squared. Then negative 7m times m squared is negative 7m to the third. Negative 7m times 2 is negative 14m squared. Negative 7m times negative 3, positive 21m. 5 times m squared, 5m squared. 5 times 2m, 10m. And 5 times negative 3 is negative 15. Find your like terms. Here's my powers of 3. Here's my powers of 2, and again I have 3 of them. And here's my powers of 1. So put those together. I have 4m to the fourth. Then negative 7 and 8 is 1, so just plus m to the third. 5 minus 14 minus 12 is negative 21 m squared, plus 31 m, and I ran out of room, sorry, so minus that 15 at the end. There's my product. All right, let's talk about the last question. In number 11, it says the area of a triangle is half the product of the base and the height. Write a polynomial expression that represents the area of the triangle pictured below. So, area of a triangle is base times height divided by 2. We want to write an expression for the area of this triangle specifically. So if I take this as the base, that's my base, and this as my height, and plug them in, here's what it looks like. I have the base, which is 2x plus 3, times the height, which is 3x minus 1, all divided by 2. Now I'm going to start by foiling the top. Whenever we have a fraction, we've got to simplify the top, then simplify the bottom, and then the very last thing we do is the division. So that's what I'm going to do. I'm going to FOIL this top. So I have first, which gives me, I didn't mean to draw that there. Sorry if that was confusing. I'll try that again. This is 2x plus 3. I'm going to multiply my outsides, or my first terms. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. 3 times 3x is positive 9x. And then 3 times negative 1 is negative 3. So that's the binomial, or the FOILed expression of these two binomials. Then I can rewrite that combining my like terms. So I have 6x squared plus 7x minus 3, and I'm still dividing the whole thing by 2. I haven't done anything with the bottom. Now, there's nothing else that I can do on the top of this expression. All of the like terms have been combined, and I can't do anything with the division of 2. I can divide 6 by 2, but that's it. I can't divide 7 by 2 evenly, and I can't divide 3 by 2 evenly. So this is how I'm going to leave this. I'm done here. I would know that my label is going to be units squared because it's an area, and that is the end of that question. Okay, so that is how we multiply binomials times binomials, or binomials times trinomials, and so on and so forth. That's our last notes video for Unit 3. Thanks for listening, and don't forget to check off your notes sheet with Miss Johnson, and I'll see you later.